All right, here's two good questions that deal with using these formulas. So an angle in radians is equal to the distance divided by the radius, and then the velocity is equal to um, the radius times the angular velocity. Okay, a bicycle tire has a radius of 29, so I have radius. And if I travel 4 kilometers, so it's a distance, s, so that's this one, the question is how many times will your wheel go around? Oh, so here I've got a formula where I know two of the variables, I can figure out the third. Let's do that. So theta equals s over r, s, 4 kilometers. Let's just immediately change that to centimeters because I know I'm going to have to get the same units. So 4 kilometers, I think that'd be 400,000 centimeters. Let me think. Centimeters to meters, yeah, that's right. Divided by 29 centimeters. So the centimeters cancel. Let's divide that, see what we come up with. Calculator here. Calculator. So 400,000 divided by 29 equals, so when you divide those, that comes with 13,793.10 radians. That's what theta is measured in, is radians. Okay, so that's radians. So that's, but they're asking how many times it'll go around. So this is radians, and I know in a circle that one circle is 2 pi radians. So one revolution is 2 pi radians. So I need to convert this from radians into revolutions. So 13,793.10 radians multiplied by 2 pi rads are the same as one rotation or one revolution. So I have to take that same answer that I had and divide it by pi, or 2 pi. So divide by 2, and then I have to divide it by pi. Divided by pi equals, here we go. So 2,195.24. They want nearest revolution. I'm giving them 2,195 revolutions. That's how many times the tire would go around if I went 4 kilometers. Okay, here's another good question. Pioneer wants to know how fast they're walking beside their covered wagon. They put a mark on one point of the wheel. Okay, wagon, wheel, cover. They put a point on one part of the wheel, and the wheel has a radius of 30 centimeters. And they start counting how many times the wheel goes around. So if they count 33 revolutions in a minute, what is their speed? Oh, that's an interesting question. So they're going 33 revolutions per minute. Now this is an angular velocity. Whoops, an angular velocity. But my angular velocity, when I want to go into this formula, this one, this angular velocity has to be measured in radians per given time. They're looking for kilometers per hour. So in this one, this I'll want to convert it eventually to radians per hour. So let's take this then, and let's multiply it by units of conversion so that I can get it into hours and so I can get into radians. Let's do the radians thing first. I know one revolution is equal to 2 pi radians. Okay, so there now I've got radians per minute. If I want to get radians for hours, then I can say, well, there's 60 minutes in 1 hour. So if I multiply and divide all this stuff, I will get a fairly big number in terms of, I think that's right, 30 revolutions, that'd be radians, and then per hour. Yeah, in an hour you probably go quite a way. So this X-ray calculator. So 33 times 2 times 60. I'm just going to leave the pi word in there. So it'll be 3960 pi radians in every hour. Okay, perfect. So this then is my angular velocity. So if I want to know what the linear velocity is, I can take my radius, which is 30 centimeters, so 30 centimeters, and multiply it by my angular velocity, 3960 pi rads in an hour. You know, thinking about that, 33 revolutions in a minute, they're probably going pretty quick. Well, we'll see. Okay, so here's my radius, here's my angular velocity. Let's times them. So I'm going to have that times 30. So I'm looking at 118,800, and this is centimeters, oh, pi, I forgot my pi, in an hour. Screaming fast. I'm going to hold it here. So this is centimeters, and this is pi. Maybe I should multiply that pi out. So let's take that number and times it by pi. So my number is 373,221 centimeters per hour. But if I want to convert that to kilometers an hour, there's 100,000 centimeters in 1 kilometer. So the centimeters cancel out. So my units will be kilometers per hour. So now I have to take the number I have and divide it by 100,000. Divide 100,000 equals 3.7322 kilometers an hour. Oh, they want it rounded to 2 decimal places. So we'll call it 3.73 kilometers an hour. So, yeah, I was thinking initially that they were smoking fast, but 3.73 kilometers an hour is probably typical of a covered wagon, maybe. Okay, hopefully that helps you with those two questions.